Check one. Okay, so I was busy talking about how I had to swap out my microphone for my thumb drive and then realized I never put it back. So hence there was no sound. Basically, I keep a lot of code bases. Sometimes I dedicate a whole project to like one thumb drive. I still use version control. It's just that if my computer ever gets toasted, I don't want to have to worry about removing the hard drive, so I keep like every very important project on its own physical thumb drive. And had to remove the microphone to check out some of this code. And we need a timer here. Countdown timer. 20 minutes. Set. Start. Okay, anyways, so I just set a timer. But this code is some ridiculously crazy C code, and I just wanted to reference it to see how I was implementing a render loop or like a game loop, because I want the JavaScript code to be somewhat compatible with the C code. It's not going to be like a one-to-one translation where I just like swap around some syntax, right? Because like for instance, I'm using like inner functions which are not allowed in C, but I'm trying not to do anything that's completely incompatible. For example, I'm not gonna ever resize an array in my JavaScript code because you can't do that in C. So I'm not gonna do it. So I want things to be kind of like well, not syntactically the same. I want both code bases to eventually be conceptually the same. So the way I do my main loop in my C code is I have this. I'm using macros like crazy, by the way. So like this TYP right here is just a macro to give this loop table struct a fully qualified namespace, so I don't have to like write namespaces before everything when I'm writing my C code. And when I use a macro, all I'm using macros for in my code is to create namespaces and to like shorten things. So for instance, T is like a type and the type is function, and I'm just but I'm not using macros for anything except for declaring types and giving namespaces to things. But you'll see all of this, yeah, all of that is namespacing. That's all like me being very specific about the different categories of the variables. So that might be a little bit crazy. Um, but anyways, this isn't. Let's not get distracted. So in this type, in the loop table type, I have like a loop timer, and then I also have a game timer, um, and I'm just thinking that I called this loop timer like LOP, but I think I'm going to call it loop table LOO table. That's a little bit inconsistent. Ah, that's fine. So loop timer, game timer, and that's just to keep track of. This is like the internal game time, and this is how many times we've looped. So the right reason why I have two variables in case we like drop, if you start frame dropping or something, or some type of desynchronization happens, this is the actual game time for the game objects. Right, so if we skip some type of game object update in one of the loops, we won't increment this. If we have to like drop rendering logic frames for whatever reason. So we have three main components of our loop table, which is just a struct defining our game loop. We have a native window function, a game object function, and then a render logic function. So basically this is, native window. So input is usually handled by the window, native window. So like keyboard input and mouse are actually handled by the native window. And this is important because when I'm thinking about how I'm going to structure my code, I'm not going to have a function pointer in here called like keyboard input or mouse input, because I realize that that actually has to be handled inside of the native window. pointer code. So I'm just going to leave it at these 3 levels, and the actual, if you need keyboard input, you got to remember that it's inside of the native window object, which is kind of obtuse, but it's an obtuse aspect of the code that has come from analyzing the reality of the environment I'm coding in. And I would have never thought of that if I had not have, been working with actual real code. If I was doing things purely hypothetically and not actually running real code, yeah, I wouldn't have a thing called native window. I just have a thing called like keyboard input, right, and mouse input. But yeah, so we're gonna keep these same function pointer names in our JavaScript code, and we'll keep the same like loop table struct name, except I think I'm gonna call it like LOO_TAB for loop table. Like keep that shorthand naming. And what else? Yeah, so I'm just gonna keep those, and we're just gonna define like a loop table struct in our JavaScript code to kind of mirror this. So let's go into our JavaScript code that I believe is still running. Yeah, that's still running. That's good. So yeah, I don't know exactly where we're gonna put this data structure. I mean, we've been kind of like throwing data structures down here. So I mean, maybe we just throw this down here. Right. So this is getting kind of out of hand. Right. We're at like, but whatever. Let's just keep on going. So we're gonna say function new, and then we're gonna call it because the loop table is a struct. It's not a function, so we're gonna give it the function naming convention of underscores rather than. I mean, we could call it like that, or we could call it loop table. But then, is that a function? Is that a class? I don't really think it's a class. We're gonna try to stay away from classes unless they're absolutely necessary. So we're gonna think of things more so as they're either functions or they're variables, and if they're variables, they're underscored, and if they're functions, they are camel case. And then on our loop table, we're gonna have var. Actually, no, it was new. Right, and then we'll call that loop table. Hello, how's it going?
I'm getting pizza.
Cool, pizza.
Come upstairs and get the set.
Okay, I got. Wait.
Well, I got a piece. So you have a couple
Okay, I got 12 minutes. Okay.
Are you gonna upload this after saying like?
It's already streaming. It's streaming live.
Ah!
It's streaming live and it's recording.
Damn,
so.
that's rough. Can I kiss you?
Okay.
Okay,
see you around.
4 years of domestic.
Stay out of. Get out of here.
Fuck you.
Okay. So let's see. Loop table, and right, we'll do an object.seal on that. Okay. And within here is where we're going to put all that stuff. So we had the native window, and then we had the render logic. So was do we call it like render loop like that? No, we called it render logic. Right, because it's not a loop. It's actually like a, this is called once per game loop. This is called once per game loop. And these are going to be function pointers. Native window, render loop, and then I believe a game object loop, like a game object. So this is going to like, if we call this like game render logic, shouldn't this be called game logic? That would be more consistent, but the idea is that this is update game objects. We could also say like aka, aka game logic. But we want to eventually just like, eventually we just got to pick a name and kind of stick to it, But now that I've kind of realized that there is that case where it could be called game logic. I'm just gonna make a note that well, it's already called, yeah, so I'm gonna make a note in my shortcuts really quick that if, so we have game objects, right, like that, we have that game object thing, and if we accidentally try to, like, later, you know, years from now, try to do, like, game logic like that, we want to make sure that we're told that we're wrong and that we already have a variable name for this, right? So game logic, game logic, and game logic tick. Update game logic update. And, okay, so for this, we'll just say, don't use game object update function, which is just going to be called, right, you know, maybe that's inconsistent, but as long as we stick to that variable name and keep it, also, you know, to justify it, I do kind of like having the, this variable is now more dissimilar from this one, and same thing as with natwin. Like, they don't share anything in this column, and they don't share anything in this column, which I kind of like that, because they're more distinctive. But, what else? So game logic, I'm gonna sneeze, oh god. Excuse me. Okay, so now that we've taken care of that, so we don't accidentally screw that up, game object update tick, we will set these to null. So these are going to be like function pointers. And then we can also have, we might as well, since we're kind of doing this, so the game time, and then the loop time. So that might be kind of annoying having, if we're gonna call it like that, and then this is LOP, because LOO stands for loop and LOP also stands for loop. But I already kind of decided on it, so maybe I should just stick with it, because that's what it's called in the other code. You know, if we go... Yeah, I might as well just stick with it. You know, it's inconsistency. Yeah, I don't know. Yeah, I also like that, to justify this, I do like that these variables now are going to be a little bit more different. I mean, they're already pretty distinctive. Yeah, whatever. Let's just commit to what we've already chosen. So, so if I type something like loo, and then if I type it wrong, I just want to make a note that if I wrong use I'm just making some notes over here. the side of the screen that if I try to use the other variable name, we're just going to disallow that. So, and then if we do it backwards, and then we'll just make a note that, and that's the loop time variable. Okay. So now that we have that, we can keep on going. So we have the game time, and we'll set these to zeros. Let me go over here again. So we're going to set the game time and the loop time to 0. So game time / game ticks, and then loop time / loop ticks. And looking at that, it would be probably important to make sure that we don't do anything called loop tick. Okay, and we have because we could also call it tick, T-I-K, right, for a ticker, but I believe, right, we could choose T-I-K or T-I-M for time or tick, but, you know, eventually we just gotta pick a concept, right, and just stick with it. So we're gonna stick for calling it time rather than ticks, going with that clean code aspect of, you know, one word per concept. Which, if you've read clean code, you're probably like looking at this and being like, how absurd for you to be quoting clean code and saying you're using concepts from it when your code is batshit insane. Okay, yeah, so we have this, and we're sealing it, and then all we gotta do is return it. Okay, so now we have this loop table object. Now we need a function. Right, we're just gonna have it as a disembodied function. So we're gonna have a function, and it's gonna be what am I gonna call it? I gotta namespace it out. What was I calling the other stuff? Did I have a namespace? I didn't really have a namespace, did it? Oh, well, I kinda did. I kinda have like a main project that I eventually want this to go into called A2JS, and that's the project namespace. I've been working on a library called that, and all the code I've been doing lately is all eventually going to go back into that library once it's all kind of like formed how I want it to be. So we'll do A2JS, and then underscore loop table tick, right? It's loop table tick. So I guess time is a noun and tick is a verb, I guess is kind of what I'm doing there. Right? And then in here, this is going to take a loop table type, right? So I just realized that I'm kind of like, you know that thing called like apps Hungarian or systems Hungarian? I'm kind of like merging apps Hungarian and system Hungarian into one, and just being like, yeah, this variable name has a very exact definition, and that definition includes its type, what it stands for, and what it does, right? So like I'm like doing, I guess it's kind of like Hungarian overkill. I don't even know what to call this. Okay, so in here, then we're just do the we could have a, so in the C code, what I do, instead of say null, I say like I have like a stub function, so we could like just throw a stub function in here A2JS loop loop table tick default function, and then we can call this one natwin, right? So this is the way I was doing it. I actually had 3 of them, 3 stub functions for each, even though they all had the same, all the functions had the same signature. And that's so that they could have a little message telling me like which function I like forgot to wire up. So we have like a default function for the native window, for the game objects update, and the render logic update, right? And then we do like a console.log, please wire up. And then here we'll have like a little thing, and then we'll say natwin, right? And then we can do that for all of these, right? We can have like little messages that let us know which callback functions for our game loop need to be wired up. And why I use function pointers like this is because it helps me remove some dependency loops in the code, especially because of the way I'm doing some of the C code. It just helps remove dependency problems, because we can create this loop table and we can create this loop table without knowing what these functions in the end are going to be, and we can have these stub functions, so like it can all be like running and working, and then we can swap these out for non-stubs in the future when we know what they are. And so we don't have to have any forward declarations for the exact signature of what these are. We don't have to define them. I don't know. It's just, it's function pointers are useful. I don't know. They help solve a lot of problems, I think. And so we might as well make a comment here that this is, you know, since we're putting comments all over the place, well, actually, we are going to run out of room very quickly, because we're gonna inline those we're gonna inline that. So we're gonna set it within the declaration of these objects. We're gonna set the functions. So we'll take the natwin and we'll put that there, and then we'll put this there, and we'll put that there. And these take nothing; they take void. So we're running out of room, so we can do some kind of weird formatting just so we get a little bit more column space. And I just want to make a note here that this is void. Right, so the function is going to return void, and it's going to take void when it's in terms of like how it's going to work in the C code. That's just to keep it as generic as possible, and that means it might have side effects, right? Because these functions might update some type of global game state. That's fine by me. Right, and then we can make a little note that these are stub functions. I mean, it's pretty obvious from what they do that they're stub functions, but then you have to read this, read that, and go, oh yeah, they're stub functions. Or you could just have a comment that tells you they're stub functions, and then you could just glance at it and not take as much time to think about it. Stub functions. Okay, so we have the native window code, the game object code, and then the render logic code. And then we also want to make a note that keyboard and mouse code logic go into the natwin function, because in C code it is the window that receives the keyboard and mouse inputs. a bit awkward. I know. No, but not change it. Okay, so just a little bit of a note in this stub function to just, because if you're trying to figure out where keyboard and mouse goes, because you're like, yeah, we have window, objects, and rendering, but where's like the keyboard stuff, you know? We want to make sure that keyboard logic goes in native window callback here. Window plus keyboard plus mouse. So just a little. So just kind of being obnoxious about it, making sure that when people are looking around, they know that it's going in there. Rendering logic. Example, GL draw arrays. Okay, and now we have that object all set up. Well, it has a default setup, right? And then in the loop table update, all we got to do is we're gonna do like we're gonna do the incrementing of the game time and the loop timer on the bottom, so that way it starts at 0. Or we could use a negative, right? So we could consider these to be integers, and we could do like -1. Specifically start at -1, so that we can update it at the top, and that way we know if we see it at -1 when we're debugging, we know that it was intentionally initialized and not just default 0 initialized. So that kind of solves two problems. So loop table dot the game time, and then just ++, and then same thing for the loop timer. So game time, and then loop time. Okay, and then within here, we'll just call those function pointers in order. So the loop table dot native window, and then the loop table dot game objects, and the loop table dot render logic. Okay, and I know like you might be confused because so far I'm kind of like showing you a tutorial on how to create like a world tile map kind of thing, and I'm adding all this other code. And the reason is I have a pre-existing code base I'm kind of keeping in mind as I'm doing this, and I want to keep the bigger picture in the back of my mind. So as I add this for the rendering logic, right? Because we do need the rendering logic to finish the thought for rendering this tile map. But as I'm doing it, I want to think about how that fits into the larger structure of the project, right? So that's why, yeah, when we want to solve the rendering problem, the native window and game object stuff is going to come along for the ride. Now, we're not going to write anything for these yet, right? We'll just keep them. We will keep them like this for now, but we will. Sorry, did I highlight the wrong things? We won't write anything for these two, but we'll keep. Okay, that's a lie. The only thing we're not going to write code for is the game objects update, right? Because we're going to need the rendering logic, and then we're also going to need that keyboard input. And that keyboard input, somehow the canvas adapter is going to interface with this for the keyboard input. We'll figure that out. We're going to have to kind of like... JavaScript is event-based, and the keyboard input and mouse input are event-based. And we're about to use like a non-event based pattern where we have like this render loop and this game loop. And so we're gonna have to like, I don't know if kludge is the right word, but yeah, maybe we're gonna have to kludge together like this event based pattern with this like linear of event loop pattern, not event loop, game loop pattern. So it might get kind of ugly, but we got to keep in mind how it would work in C, where we're not doing things event-based, and kind of like shoehorn it a little bit. So the code might get a little bit awkward, but there's always going to be like a very well thought out intention for why things are the way they are. If that doesn't make sense by how long these videos are and how many videos there are for something that you could probably do everything I'm talking about, in like probably like 20 minutes to an hour. Well, maybe not 20 minutes. It depends on how complicated you want to get, like how structured you want to get. Yeah, you probably couldn't get this structured in 20 minutes to an hour. You would need more time. But to just like whip something up really quick and dirty, yeah, 20 minutes to an hour, you could probably do it. But I'm not trying to do things quick and dirty. I'm trying to get something nice and sturdy. Oh, that kind of rhymed. Quick and dirty, nice and sturdy. Okay. So now that's there. The next thing we're going to do is we're going to try to figure out where to put this. So this needs to go into the don't call directly, call from our function container object. It's like, I don't know, our function container object might be kind of useless, because, like, why not just call it directly? But, I don't know, I just have a hunch that using our global functions container is going to help organize our thoughts and formalize that rigid structure of the order at which data should be declared. Because right now, if this were C code, this function would need to be above all of the data to fit into my pattern of data, then functions, then classes. And so by packing this into the global functions container, we can kind of formalize that this, though it may be floating down here, actually belongs like positioned kind of in the middle of the code, not at the bottom down here. Because of that separation of the different types of, types of types. Yeah, because functions are types, and objects are types, and, yeah, whatever. Okay, so I'm going to stop this now, because my time is up. I need to go upstairs, see what's going on up there. And then I'll be back, and we'll just keep on hashing this out and building this monstrosity that was supposed to be a very short tutorial that is now like a few thousand lines.